Chapter 13, Restoration Ecology. As we have seen, human impacts are responsible for many of the environmental impacts facing us today. While much of our discussions have involved ways to reduce our impacts, what do we do once they have already occurred? One branch of science that addresses this is restoration ecology. As its name implies, it is concerned with fixing the damage we have done. While you may think restoration means returning an area to its pre-human state, that just isn't the case. We can rarely restore an area to a pre-disturbed state for several reasons. First and foremost, we rarely know what that pre-disturbance state may be. Humans have been impacting the environment for a long time. Second, even if we knew what it used to be like, it would be a general idea since we may not ever be able to know all of the precise details of an ecosystem. Any restoration would be our best estimate of how the system was structured and should work. Finally, we need to be pragmatic in our efforts and realize we must work within our technological and ecological boundaries of what we know today. A flowchart of ecological restoration. When conducting restoration, we may intercede at different levels of restoration, and how we do it may differ. Because of this, we use terms which help define those levels. For example, rehabilitation is repairing an ecosystem to function as it did in the past, but not to an original condition, while remediation is the use of some chemicals, biological, or physical method to remove pollutants. Because biomes, or ecosystems, are comprised of living, biotic, and non-living components, abiotic, our approach to restoration must include physical and natural science concepts. This makes restoration ecology an interdisciplinary science, drawing from experts in many fields. Regardless of the approach taken, most restoration projects have some elements in common. For example, they almost always work to remove the stressor to the environment which causes the original damage. It wouldn't make much sense to restore an area if a pollution source was still there to just damage it again. Other elements, including replanting areas, releasing animals back into the area, and monitoring the progress and ecological succession of the area. One of the largest restoration projects in the U.S. is the restoration of our native prairies. Prairies are almost completely human-dominated, with only 2% of pristine prairie left. I have actually worked on a prairie restoration project in Missouri. Our responsibility was to survey the small animals in the restoration area, mice, shrews, rats, etc., to determine their species composition, richness, and complexity. We then compared our numbers to the numbers in pristine prairies to compare how well the restored prairie mirrored the pristine prairie. Based on this data, decisions could be made about the best management approach. Based on our results, it was determined that fire and periodic burning was a necessary management technique needed to restore the prairie in that area. A map of prairies in the United States. Fire is also crucial to prairie restoration. In 1934, Aldo Leopold began to recreate tallgrass prairie on an abandoned farm in Madison, Wisconsin, now the Curtis Prairie. He discovered that fire was essential. It kills weeds and removes soil nitrogen, which gives low nitrogen native species an advantage. Nature Conservancy has tallgrass prairie northwest of Tulsa, Oklahoma. 1/3 of each pasture burned per year, and bison have been reintroduced. Another project I have worked on is the restoration of Spartina salt marshes along the Gulf Coast. Wetlands occur along the water-shoreline interface and are prime areas of development. Who wouldn't want to live on the water? Because of that, marshes and wetlands have been heavily impacted. A photograph of a wetland. Wetland restoration has become a priority with several federal laws enacted to reduce the damage and to protect them from future damage. Because of this, wetlands have increased in size. One of the most helpful restoration plans is to return diverted water, it is usually diverted for agriculture and development, back to the natural flow. The results have been very successful in many areas. Other organisms benefit when wetlands are restored. For example, in the upper Midwest, agriculture had huge impacts on the pothole regions of North and South Dakota. As farmers plowed their fields, these potholes were smoothed out and wetlands were lost. Monies taken from hunting permits were used to restore these areas. Because of this, the wetlands increased and migratory duck and goose populations rebounded. While this is good news, not all mitigation and restoration efforts worked as well. Developers are often given permission to destroy wetlands with the requirement that they restore or build a comparable system somewhere else. Unfortunately, the mitigated areas are often not successful. A photograph of wetlands. Streams have also been impacted, especially urban streams, resulting in heavy channelization and loss of riparian zones. Many cities are removing these channels and restoring the streams to a more natural state. Evidence shows this helps move the water downstream from the city, and it can help reduce flash flooding. Streams need rebuilding. Reduce sediment entering streams by providing ground cover. Redirect water with earth-moving equipment and barriers to deflect current. Provide fish habitat with logs, roots, artificial lunkers. Stabilize banks by having slope of no more than 45 degrees.